Hello everyone, this is the second tutorial for exception handling in Python. We will cover exception customization, specifically when we use raise state. The exception can be customized based on conditions by using dedicated Python keywords such as raise, and later we will learn also assert together. The exception can be enforced based on rules or considerations by using raise exception, in which we raise an exception or a message showing that the event has been faced and will interrupt the execution. Let us translate what I'm introducing by start coding. Suppose I have a variable that will hold the age, and this age, for example, 35. Okay, I can use condition here if the age that will be lower than 32. Okay, then what I have to say at this point, I can raise error. Okay, or sorry, I can raise exception. Okay, so I can use the statement raise, which is used to raise exception. Okay, and inside this exception, I can submit my message. Okay, this message will be printed to the end user. So I can say that age should be, for example, greater than 32 or something like. So let us execute this line of code. Because the age is 35, it's not lower than 32, then I have no exception. Okay, then if I modify the age to be 30 and the condition is 30 to be to be greater than 32, now I will have exception. Then a message will show to me here, and this is like trace back message. Later you want to learn more about this, but now you have to be focused on using raise. This raise will raise exception. The exception will interrupt the execution and show me this message: age should be greater than 32, which I inserted here. So raise mainly is used to raise exception with a message that will be printed or be visualized in case there will be interruption in the code or there will be some errors. Okay, let us give another example. Suppose I have this function that will use to divide n1, which is the number 1, and n2, okay, the second number. Look at this. If the number 2 will be 0 or will be equal to 0, then I will raise. But I don't need to raise a general exception. I want to raise 0 division error. And I can customize the original message that embed with this 0 division error to be like cannot divide by 0. Okay, so I did nothing, just I defined a function, and in a certain condition, if I will find the divisor will be 0, then I want to raise 0 division error. However, I can raise exception also. Okay, so both are working. Let us start with exception, and I will modify to 0 division error. And in case if there will be no exception, I will return the number 1, okay, over number 2. Now, what I will do now, we learned how can we use a try except. Why not to use it here? So I can use a try. Then after using a try to wrap the block of code, I want to introduce the result, and this result will be the result of the division. Okay, so I am invoking the function here and calling it, and I want to submit as the first argument the value of the first argument 10, the second is 0. It's just to match with this condition. So number 2 here, which is here, is equal to 0. Then I want to use except to raise exception. Okay, as E, and I want to print E now. Remember that E is the exception Okay, so when I use as is, then I will like reduce the whole word into letter, and this exception is the class. So later you will also be able to modify this class. And now I want to print E only. So E here, which is the exception, is the message that is appended to the exception inside the function. So I use try except here to call the function, okay? And inside this function, I identified exception with a specific message, okay? And I wrote here accept exception as E, and E is this exception, okay? Now we have the cannot divide by 0. I can say here also 0 division error, but also will use here accept exception as E, and the exception here is the 0 division error, but you should be consistent as what we learned together. And so if you have a certain exception, you define inside a function, and when you recall the function, use the same exception name just to follow or trace the function, the exception and the function wisely. Let us also cover another example. Suppose that we will move from using function to object-oriented programming. I will now design a class, and this class will hold my bank account. Sorry, this is my bank account, and in the constructor of my bank account, remember init as what we learned together is called constructor, in which I identify the parameters that I want to submit when creating the instance. I will only submit the balance. But before storing, so we learned that we use self.balance or whatever you want to learn to store the value of the balance. But before going to store the value, I want to do a check here. If the balance will be lower than 0, and this is not allowed for a specific task in the bank, so what I will do, I will raise, okay, now another exception, which is value error. This is like another exception type. So here, when I say exception, this is in general exception, but the exception has many different forms. So in the previous example, we covered 0 division error. Now I want to cover value error, because the balance will go to negative, then the value will go to negative, then I will have now value error. And I want to print the exception. I want to say balance cannot be negative, okay, like this. And I want to, this balance should be maintained here. And yeah, I have a class that will only come with one attribute, and the first thing is to check if the attribute is negative, then I will raise this exception. Otherwise, I will store this inside the class. Okay, what I will do now, I will use a try except to make this an instance. So I can say, for example, bank, okay, account, bank account, this account will be like this. This is an instance. So we learn also in the object-oriented programming series that we can create the instance, but I look to the constructor in it. If I see any argument here or any parameters, I have to insert it here. I will enforce this balance to be minus 100 just to activate this exception. Okay, and I will later say that except, and except what we learned that we can use general exception, but I prefer to follow the exception that I already identified. So I have value error as E, and I want to print E now. So if I print E, then I will see that I customized, okay, the exception here. So I can say like this, and I can execute, then I will have no message. However, there is exception, but there will be no message. Okay, and if I will submit a random message, it will be a pair, but really be consistent in your code. If you use raise, you have to submit the right message, and if you don't use that, then you will have you will have a problem if you want to continue in the code execution after, in case if there will be exception. Please go to the previous tutorial to learn more why we need the exception handling in general. So we covered the primary raise, and we give example of age, and we use raise directly. Using raise directly at the beginning entail here like red flag or red message that interrupt the code. Then we use a function. We use the function, and the function also entails message. Now we used another example using the class, and yeah, this class also can be wrapped when I make the instance inside the exception handling. Okay, now I want to give another level of customization by using a class inheritance. If you don't know the class inheritance, go back to my object-oriented programming series here, and you will learn more about the class inheritance. In general, I design a class by using the statement class. Then I will design a specific class. It's my class, so I will say negative. Okay, age. Okay, error. I want to like design the specific. You can give any name you want. Okay, then I want to do inheritance. We learn together we can do inheritance by calling the original class inside this class. Exception handling are designed in Python with the exception class. So I use exception as a parent class. So I inherit, okay, inherit now inside the negative age error, okay, exception. So the exception is the parent class, and I don't need to make anything. If you don't need to make anything now, so you can use either ellipses or use pass, okay, both are the same. Now I want to define a function, so I just like call the parent class, and I have negative age error as a new exception, but still now we don't know anything about it. Now let us design age function, and the age I expect usually to be positive, okay, and if the age, like if the I will give different just to not to be confused. Sorry, it's not a matter of age. If the x, because x will be the argument that will represent the age. If x is lower than 0, for example, then what I will do? If it will be lower than 0, then I will use the raise statement. But I do not need to use like anything other than the negative age. So I don't need to use general exception. I do not need to use value error. I will use my own exception that I designed. So this is like a footprint or a flag of my new exception. So I want to raise a negative age error that I just designed. I will submit the message inside this, and I will say negative age is not allowed. Okay. Now what we will do, so here we did the inheritance. I give a label to my class, then I to my exception, then I design my function, okay, and what I will do, I will use it try except now. So try except just wrap like recalling the function, okay. So when I use this, so I want to call the function, and I want to submit the age to be -10 years, then I will use except negative age error as e, then I want to print e. Well, if you want to use e, or you want to eliminate this and use negative age error, but I want to print e, okay. Now I will have negative age is not allowed. This is a new exception. I designed it, and I can keep it to any project based on like any application I have, okay. So now we have another level of exception customization, not by using the default exceptions like value error or type error. No, I identify here a new exception. Let us like create another task here. Suppose that I will have, for example, another class. Let us so suppose in the application the age also is restricted to be only integer age, not float. So I can design another exception. I can name it like a float age, and this float age will also be inherited from exception. Okay, remember to do inheritance to have the customization. Okay, to the exception, and in the constructor here, I want to do something. This is init, not the constructor. We have to use init. Okay, and I will submit the age here, and I will submit also a message that will be shown. So I want to store the value of age in the self of age, and I want to store the value of message in the self dot message. Okay, sorry, MSG. Okay, this is just to give a name to the exception, and I want at this stage to print the exception also in this case. Now I will also define define the age here. Okay, let us define the age. For example, I will remove this one. Let us define the age here, and if now not x, if the type of the x now will be float. So if this will be float, then what I will do, I will raise now float age error. I can say float age is not allowed. Okay, this is very simple. So now you are able to have any error, any exception, and a new exception, and you can customize this with your code. Let us wrap the code in the try, and we will create now the age, for example, of let us to say 10.2. This is a float, and I can say except. Okay, let us give negative error as e just to maintain the consistency. Print e, and I want to say accept float age as e. Also, I want to print e. But what can we do here? I want to check also if x itself is lower than 0, then I want to raise the negative age error, error that I just eliminated. Okay, now in this case we have, in this case we have the float age here will be transferred or not to negative, just to have two specific exceptions. So I have the first class exception here, the exception here, which is negative age error, and I have the float age, another exception. I have a function that like called both exceptions. These are totally new exceptions that are not located with Python, but I already designed these. And now let us try with the code, and we have error because when I created the float age, the constructor of the float age required me to pass two things, not just the message, which is here, but I have age, so I am enforced to pass x here. Okay, so I enforced to pass x. Remember, if you design any class, keep your eyes to the constructor, check how many arguments are located within. This should be matched, so this should be matched in terms of argument. And what is good here, either I can print e, or I can print e dot, for example, message if I want to show the message only, or can I print even access the value if I want to access the e dot age. So let us execute. Now I have the message, which is print e. It comes here in the first line, because I designed the exception to have two arguments or two attributes. But I can eliminate this. I can only print the message if I want, which is a float is not allowed, because when I created here the function, then this function contains a float age. And that's for today's tutorial. And the next tutorial we will learn also how can we use assert or assertion error, and how assert is used to verify the data type or the data representation in Python.